Okay, hello. So this is the omnidirectional antennas have a similar radiation pattern, and this antennas provide a 360-degree horizontal radiation pattern. These are used when coverage is required in all directions horizontally from the antenna with varying degrees of vertical coverage. Polarization is the physical orientation of the element on the antenna and that actually emits the radio frequency energy. An omnidirectional antenna, for example, is usually a vertical polarized antenna. In this figure, there are two types of, one is a horizontal directional, one is the vertical directional. So omnidirectional antennas, what I'm saying in the we already discussed that omnidirectional is a 360-degree horizontal radiation pattern, and that is used when coverage is required in all directions, right? So the from the antenna with varying degrees of vertical coverage also. So it is the vertical directions and it is the horizontal directions antennas. So mainly our omnidirectional antennas you are using when your coverage area, suppose you want to cover in the surrounding coverage, that means 360-degree coverage. In that case, you are use the omnidirectional antennas. Clear now? Just like for example, suppose you are using a modem, there is an antenna on that device. So that is a omnidirectional antenna. It will cover all the directions, right? So that is depend upon your covering areas, your antenna you are using. Next is your directional antennas. A directional antenna is a radio frequency RF wireless antennas designed to function more effectively in some directions than in others. The purpose of that directionality is improving transmission and the reception of communications and reducing interference. In consumer applications, the most common directional antenna is the dish used with satellite internet and satellite television installation. So directional, what is the advantage of the directional antennas? You cannot say the advantage because according to the requirement your antenna generally are using, you can say that omnidirectional is some disadvantage and directional is some advantage. No, as your requirement the antennas generally are used. Suppose you are 360-degree coverage, but I am saying like the antennas placed on the modems and there is antenna in the vehicles. It is omnidirectional antennas because it try to cover all the 360-degree directionals, right? But the directional antenna like your dish TV antenna mounted on your roof of your house, so that is the directional antennas because it will receive the data from a particular direction. Sometimes it is used to reduce the interference, right? It reduces some interferences, and that's why the directional antennas are used for to reduce the interferences from the receiver and the satellite communication. So in consumer applications, the most common directional antenna is the dish used with satellite internet and satellite television installation. So depending upon the requirement of the user, you can use the antennas, whether maybe the directional antennas or maybe the omnidirectional or omnidirectional antennas. Next come to it is known as the signal propagation. So signal propagation again is nothing but traveling signals through some mediums. There are two type of mediums are using. One is guided mediums, everybody knows that. Under the guided mediums, there are cables are used, twisted pair cables, OFC cables and the coaxial cables. But here we are only focused about these unguided mediums, right? The ground propagation, sky propagation and line of sight propagation. These are under the unguided mediums. So the electromagnetic spectrum classifies electromagnetic energy according to the frequency, and signal propagation is nothing but traveling of signals through some mediums in case of both wire and wireless network. The transmission media is of two types. Everybody again I'm repeating, that is the guided and unguided mediums. In case of guided medium, it will be divided into That means there are cables are used, twisted pair, coaxial and the coaxial cables. And for the unguided mediums, that's where the signals traveling through the air, and there is a ground propagation, sky propagation, and the line of sight propagation. So in first is a ground wave propagation. So in ground wave propagation is a type of radio propagation which is also known as a surface wave, and these waves propagates over the earth's surface in low and medium frequencies, and these are mainly used for transmission between the surface of the earth and the ionosphere. That means it will happen between the earth's surface and the troposphere, because between the ionosphere and the curvature of the earth sphere there is a layer is known as the troposphere. And the reason why it is known as ground wave is that it is the sum of the waves that reflected by Earth's surface or any hails. That means the substances present on the curvature of the Earth. These are the only the reason to help to propagate the signals. The waves follow the curvature of the Earth and enabling them to cover beyond the horizon. Clear? So that is the ground wave propagation technique. First thing that this will happen between the curvature of the earth's surface and the troposphere, and totally dependent upon the substances present on the earth's surface, like hills or mountains or the buildings. By help of this reflection property, the signals will be transmitted from the sender to the receiver antennas. Clear now? So, and it also the waves follow the curvature of the earth, enabling them to cover beyond the horizon. Right, the beyond the horizon, where the horizon means what do you mean the horizon? The horizon means is your, this is the between the earth surface and the upper part of the curvature of the earth. So the ground wave propagation is used the low transmission, mainly used for transmission between the surface of the earth and the ionosphere. This is the advantage of ground wave propagation. These waves have the tendency to bend around the corners or obstruction during propagation, and which makes them more efficient, and also these are not affected by the change in atmospheric conditions. But disadvantage of ground wave propagation, high frequency wave cannot be transmitted as the energy losses are more because of the absorption of energy in the earth's atmosphere. So disadvantage that you cannot use for the high frequency communication through by this ground wave system, because due to it is the very nearer to the earth's surface, so the energy losses are more due to the absorption of the earth's atmosphere, and these are used to cover short range and also inverse attenuation of waves as they interact with the eddy currents produced by the surface of the earth. And what are the applications of ground wave propagation? This can be used for one-way communication from the military to submerged submarines as they penetrate with significant depth into sea water. AM, FM and television broadcasting can be done with the help of ground waves. So in the submarine case, you can use this ground wave propagation, through which you can send the signals and everything is there. So moreover, there is some advantage for short range frequency signals when transmitting the signals, but disadvantage that though it follows the curvature of the earth and the substances present on the earth, the data loss will be also the more, because it observed by the surface of the earth's atmosphere. And again the application, the best example is the submarine application. Next comes the second type of wave propagation, is known as the sky wave propagation. The signals are reflected from ionized layer of the atmosphere known as ionosphere. The signals can travel number of hops back and forth. Like in this figure, that is the ionosphere and this is the earth's surface. And here the signals can travel number of hops and back and forth. So, and it will dependent upon the ions present within the ionosphere, because generally ions are the chargeable particles which are held to the transmit the signals. So in radio communications, skywave or skip refers to the propagation of radio waves reflected or refracted back towards Earth from the ionosphere.